In this video, we will talk about lines in space, and specifically we will see the parametric form, and we will see many examples how we can use them to solve various problems. So let's start. So if we have a point P which is given in 3 dimensions by its x coordinate, y coordinate and z coordinate, and similarly we have a point Q will have the same x, y and z coordinates, and let's say these points are on line, some line L, and note that a straight line is fully represented by only 2 points. Okay, then we have a direction vector which is also given by the vector going from P to Q, which is P1 minus Q2, P1 minus Q1 and P2 minus Q2 and P3 minus Q3. Okay, so this is actually a vector going from Q to P. So then this is from Q to P. Okay, so then the parametric equation of the line is given by, so this should be actually Q1, Q2 and Q3. Okay, so this is Q1, Q2, Q3. Why? Because we are saying this is the story here. So we have Q1 and we have Q and we have P. So the vector going from here to here is this minus this. So this is P1 minus Q1, and so this is my starting point and this is my ending point. Now note that here, if I put t is equal to 0, it means I am at Q, and if I have t is equal to 1, this means I am at P. If I have t less than 0, it means I am to the left of Q. If t is greater than 1, it means I am at the right of P. So right and left are just labels here. So what it means is that if we are going from Q to P, then if t is between 0 and 1, we are in between Q and P, and so on. Okay, so this same story can be given by the vector as well. So the vector form is given by R is equal to P plus AT, where this should be actually Q. This is a vector Q and this is also a vector Q here. Okay, so this was a typo, I'm just correcting it on the go. Okay, and whose terminal point is where? Whose terminal point is point Q. So the situation is like this. So we have this line, so that, and this is the origin here. So this is 0, 0, 0 here. So I'm saying that this vector plus some direction vector times some coefficient gives me this vector. So this is my Q here, and this is my Q vector. So this is my Q vector here. This is my Q vector, and this is my A vector times some coefficient, and my P is somewhere here. Okay, so this means that if I have t is equal to 1, then I will end up with this vector. So somewhere in between Q and P, I have some value of Q. Okay, some value of t. So hope it makes sense here. Okay, so now let's see how we can use this story to find different results. So now first of all, what we want to do is we want to find the angle between two lines. So this is my line 1 and this is my line 2. Okay, so what is the direction vector of this guy? So the direction vector of this guy is, so I'll say direction vector is -2, 3 and 5, and this is 5, and similarly direction vector of this is 1, 4 and 1. So how do we find the angle between these two lines? We can just find the angle between these two vectors. And how do we do that? We know that cosine of angle, this is equal to the dot product of two vectors divided by the magnitude of these two vectors. Correct? So the dot product is what? -2 times 1 plus 3 times 4 plus 5 times 1 divided by, so this is 4 plus 9 plus 25, so which is equal to what? 38 square root. And this is what? 1 plus 16 plus 1 is 18 square. Okay, so whatever this number is, so theta is equal to cos inverse of this whole story. So I think this comes to be as 55 degrees. Okay, approximately. Okay, but I mean the actual number is not important. The important part is that if you have two lines here, what do? We find the direction vectors by the coefficient of t here. From coefficient of t here, from here we can find the direction vector, and we can find, using the dot product formula, we can find the angle between those two vectors. Okay, so let's go to the next example. Now we are interested in the point of intersection between two lines. Okay, so there is possibility that these two lines intersect, and there is a possibility where these two lines do not intersect. So let's see whether these two lines intersect or not, and we will see while we are doing the problem, we will see what are the conditions here. So let's take this equation and this equation. Okay, so we have 1 plus 2t, this is equal to 4 minus v, and you can choose any two of them. So this is 5 minus t, this is equal to 4 plus v. Okay, so what do? We can just add them. So we have addition, so no sign is changed. So now, okay, so 1 plus 5 is 6 plus t, this is equal to 8, right? Not 10. So this is now gone. So t, this is equal to 2. Okay, so t is equal to 2. So now we put t here maybe. So 5 minus 2, this is equal to 4 plus v. So this means 3 is equal to 4 plus v. V is equal to minus 1. So I get v is equal to minus 1 and t is equal to 2 here. So how do we check? We check by using the third equation here. So we'll check 1 minus 4 times 2. So this is equal to negative 7. And if I put v is equal to here, v is equal to this value here. So 1 plus 6 times minus 1. So this means minus 7. So this means, since the third equation is verified by solving the first, by putting the answers of the first two equations, so this means they intersect. So this means the first part is they intersect. Okay, so now it's a piece of cake. Now we can put either the value of v here or the value of t here. So it doesn't matter which one we choose. So let's choose this guy. So we have x, this is equal to 4 minus 1, which is equal to 5. Similarly, y is equal to minus 1 plus 6 times minus 1, which is minus 7. And z is equal to 4 plus minus 1, which is equal to 3. So the point here, my answer is 5, negative 7 and 3. Now note that there is one small thing to notice here is that we have different variables here. We have a v here and we have a t here. Now if I put t here and then solve for 1 plus 2t is equal to 4 minus t, it will not work, because the movement, the parameter for one line is different from the parameter from the other line. So this is very important. So if you choose the same variable for both equations, then you will not get the right answer, because this line is represented by some other direction vector, and its speed, so to speak, is different from that point's movement as on that line is different from this line. So the question point is that use different variables or parameters for different lines. Okay, this is very important. Okay, so now this is just another information for you, that if the lines are not parallel, neither parallel nor are intersecting, they are called skew lines. Okay, so these are the lines which are on a different plane, so they never intersect, but they are also not parallel. In dimensions, if the lines are not intersecting, they have to be parallel. Correct? Okay, now we are interested in another type of problem. We are saying that line through point P, which is orthogonal to the line whose parametric form is known. So we are interested in a line whose point is this and which is orthogonal to this. So what is the direction vector here? This is what are the coefficients of t? 1, 1 and 1. Okay, so then if the line which we are seeking is orthogonal to this line, so this means that direction vector, let's say that is v, that should have a dot product with a is equal to 0. Correct. Now this can be any so many vectors here. So let's choose b. This is equal to -1, 2, and something else here. So if it, remember, we have to make the dot product 0. So -1 times 1 is 1. 1 plus 2 times 1 is, sorry, -1 times 1 is -1, and 2 times 1 is 2. So the sum is 1. So I should have a -1 here. Okay. So this is one potential candidate for B. And if it passes through here, then my answer is just the starting point plus -1 times t. This is my x. My y is this number plus this number times t, and z is equal to this number plus this number times t. So this is the equation of the line which I am seeking. Now there is no one unique answer here. You can find some other direction vector here which is orthogonal to this, and these coefficients will change. Okay. So this is about this part of the problem. Okay. Now we are interested in point on a line which is equidistant from two other points. Now we have a line here and we want to find 2 points. We want to find on a point on the line which has the same distance from this point and this point. So the situation is something like this. We have this line, let's say, and this is one point, this is P, and this is Q. So we want to find maybe this point whose this distance and this distance is equal. So for example, this distance is D, and so this distance is D too. Okay, so we are interested in this point. Okay, how do we find it? So all we do is we want to find the unit. How do we find the distance between 2 points? We use the distance formula, correct? So let's say this is the point here. So this point is what? This point is what? 2 minus t, 1 minus 4t, minus 2 plus 4t. Okay, so what is the distance between this and this? So this is what? 1, 2, 3, and this is what? 0, 1, and 1. Okay, so what is the distance between this and this? This is 2 minus t minus 1 squared plus 1 minus 4t minus 2 squared plus minus 2 plus 4t minus 3 squared. So this is equal to this distance. So this is again, this is what? 2 minus t minus 0 squared plus 1 minus 4t minus 1 squared plus minus 2 plus 4t minus 1 squared. Correct? All now we have to do is we have to do some algebra, open it, and combine like terms and solve. Okay, so this is what? This is 1 minus t. So I can say 1 plus t squared minus 2t. Okay, this is what? This is minus 1 minus 4t. Correct? So this is plus 1 plus 16t squared plus 8t. Correct? So this is what? This is minus 5 plus 4t. So this is plus 25 plus 16t squared minus 40t. Correct? Okay. So if there is some algebra mistake, don't worry about it. I mean, I'm doing it in my head. But the point here is that after this is simple here. So 2 minus t squared. So this is 4 plus t squared. This is minus 4t squared. So plus 16t squared plus. So this is what? Minus 3 plus 4t. So plus 9 plus 16t squared minus 24t. Okay. So now note that this 16t squared goes. This 16t squared goes, and this t squared goes. Okay. Now how many t's we have? Minus 2 plus 8, so plus 6 minus 4t is minus 34. Minus 34t. And how many t's here we have? We have minus 4 and minus 24. This is minus 28t. Okay. Now the constant term, so this is now taken care of, this is taken care of, this is taken care of. So 1 plus 1 plus 25 is 27. This is now done. And then we have 4, and this is also taken care of. So 4 plus 9, so which is equal to 13. Okay. So now what do we get? We have 27 and 13 here. So I can say 14 here. And minus 34 and minus 28. So I can say plus 60 here. So this means my t, this is equal to 14 over 6, which is equal to 7 over 3. Okay. Now I have to adjust, we are interested in the point, right? So my answer is 2 minus 7 over 3, 1 minus 4 times 7 over 3, and minus 2 plus 4 times 7 over 3. So whatever these numbers are, this is the point whose distance from these 2 points is the same, and it also lies on this line. So this was very simple. It was a little bit lengthy because we had to do some algebra here, but it's not hard. All we have to do is use distance formula and simplify and simplify. Correct? This is all we did. Okay. What next? Now we are interested in the shortest distance from a point to a line. So the situation is like this. We have this line, okay, and we have this point, okay. Now the shortest distance is what? The shortest distance is the perpendicular distance. So this is my P, and this is my line L, whose equation is given to me, and I'm interested in this distance here, D. This is what I'm interested in, okay. So first of all, so this point is what? This point is some t. Let's say this point is again the same story, 3 plus 4t, 4 minus 5t, and minus 2 plus 7t. And this point we already know, 2 minus 6, 1. Let's say this point is, let's say, q. So the vector, I will say qp, this is, let's say this is b. Okay, so this is equal to this minus this, correct? So I will say 2 minus 3 plus 4t, which is 2 minus 3 minus 4t, and then minus 6 minus 4 plus 5t, and then 1 minus minus 2 minus 7t. Okay, so then this guy is what? Minus 1 minus 4t, minus 10 plus 5t, and 3 minus 7t. Okay, okay. So this is this vector. Now this vector should be orthogonal to the direction vector of this line, right? So then this means that 4 minus 5 and 7, dot product of this guy and this guy should be 0. Why? Because we are interested in the perpendicular distance. So this is the shortest distance. So then all we have to do is we have to say 4 times minus 1 minus 4t minus 5 times minus 10 plus 5t plus 7 times 3 minus 7t, this is equal to 0. Okay, so this becomes minus 4 minus 16t plus 50 minus 25t plus 21 minus 49t. So this is equal to 0. So now 4 minus 4 plus 50 and plus 21 will give me 67, and minus 16t minus 45t and minus 49t will give me minus 90t. This is equal to 0. So this means t is equal to 67 by 90. Correct? If t is this much, then what are we interested? We are interested in the distance between this and this. Correct? And so this means all we have to do is we are interested in the magnitude of this vector, correct? So we are interested in B magnitude. So this is equal to -1 minus 4 times 67 over 90 squared plus -10 plus 5 times 67 over 90 squared plus 3 minus 7 times 67 over 90 squared. So then this is, you have to do is square root of this whole story. This is also in the square. Okay, so this is my B. If you do it, you will get around, I would say 7.75. I've added it on my own, and I hope there is no algebraic mistake. I don't think so. What we have to do is, all we have to do is we have to find the magnitude of this vector here, because this vector is from here to here. Okay. Okay. So in summary, what we did was we talked about a parametric representation of a line, and we see what kind of problems we can solve by using this parametric form of that line. Okay, so we also made use of the distance formula. We also made use of uh, the dot product. Okay, and we also did some basic algebra to simplify. Okay, hope it was easy to understand, and thanks for watching. Hope you liked the video.